Okay, so this is the Chemistry Live workbook, page 66, question 16. Okay, so again, you're given a goal which looks like this, and you're given three equations which look like so, and you're trying to prove that Hess's law, okay, so Hess's law states that if a reaction happens in one stage, which is essentially this, or if it happens in multiple stages, the overall heat change, so the sum of all these little heat changes, should be the same. Okay, so what I'm going to do here is just, first of all, look at what's my reactants and what's my products. So the reactants here are what's on the left-hand side of the goal equation. The products are over here, or what's on the right-hand side. It doesn't matter if at this early stage in chemistry you don't exactly know what these are, okay? I would expect you to know what CH4 is, and if you aren't sure, then just draw it out. So 1 carbon and 4 hydrogens, it's going to give you methane. But at this exact moment, I don't expect you to know what all these chemicals are. We just need to know how to manipulate them in this little equation. So on the left-hand side, I need methane. I'm checking if I have methane on the left-hand side in any of my reactions, and I do. I have it right there. According to the goal, I need 2 methanes. I only have one of them here, so I need to multiply this line by 2 in order to get 2 methanes. If I'm doing that, then the heat change for this equation must also multiply by 2. Second thing I need is an oxygen. I have an oxygen down there on the left-hand side. On the right-hand side, I need CH3OH, and I have CH3OH right here, but I only have one of them. According to the balanced equation there, I need 2 of them, which means I also need to multiply everything in equation number 2 by 2, which means my heat of reaction is also multiplied by 2. At this stage, I'm fairly confident that I have everything in my goal in these equations. So I'm going to rewrite out the 3 equations, but this time I'm going to include the alterations that I've made. So to reaction number 1, I've decided I'm going to multiply everything by 2. So instead of having 1 methane, I now have 2 methanes. Instead of having 1 water, I now have 2 waters. I now have 2 carbon monoxide, and I have 2 times 3, which is 6 hydrogens. The heat of reaction likewise is going to be multiplied by 2. So 206 by 2 gives you 412 kilojoules per mole. And I'll put in a big fat plus sign in front of it because it's still positive. To reaction number 2, I need to also multiply everything in this line by 2. So 2 times 2 is now 4 hydrogens. 2 times 1 carbon monoxide is now 2 carbon monoxides. 2 times this new molecule is now 2 times CH3OH. The heat of reaction likewise is multiplied by 2. So minus 128 by 2 gives you minus 256 kilojoules per mole. And to the last equation, I've decided I'm not doing anything because there's no alterations here. So I'm just going to rewrite it out exactly as it looks. And I'm going to hope that it all balances out. So sorry, 434 kilojoules per mole. So I'm going to hope that it all works out. Now, at this stage, I can ignore these original 3 equations. I'm only focused on these ones. What's on the left-hand side up here in my reactants is 2 CH4s, and here I have 2 CH4s. 1 oxygen on the left, okay, all on the left. On the right-hand side now, I need 2 CH3OH, and here I have 2 CH3OH, and that's all I need. So I'm hoping at this stage, everything on the left-hand side will cancel with everything on the right-hand side. So on the left-hand side here, I have 2 waters, 2 H2Os, and they cancel with those 2 H2Os on the right. On the left-hand side, I have 2 carbon monoxides. They cancel with those 2 carbon monoxides on the right. And on the left-hand side, I have 4 hydrogens and 2 hydrogens, which in total is 6 hydrogens, and they cancel with those 6 hydrogens. So at this stage, I'm confident that my equation has worked out. I now need to rewrite out the goal equation which was given to me. And in order to find the overall heat of reaction, I must add together these 3 heat of reactions. So plus 412 minus 256 minus 434 will give you minus 278 kilojoules per mole as my overall heat of reaction.